.NET 10 Preview 1 with Daniel Roth.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software architecture and engineering firm that serves companies using Microsoft technologies. We build mission-critical software, rescue failing projects, and inspect and advise other teams, always empowering software delivery teams with a proven approach. I am excited to announce that my latest book has been fully released. It's about software leadership. It's called The 5 Pillars, Leadership for Effective Custom Software. And the book is for anyone attempting to make a custom software team highly effective. So if you want your team to deliver world-class results, the book may be for you. And teams are doing book studies and discussions around it, and I'm excited about that. So if you, dear listener, would like a complimentary electronic copy of the book, just send me an email and I'll be happy to get it to you. And for those of you who are in a lead architect or software executive role, you might be interested in our monthly forums. We do those over video call. They're interactive and deeply technical sessions that I enjoy facilitating, but it's a peer group. And you can sign up on clearmeasure.com. And also, we just launched a new lead engineer live stream on YouTube for software engineers looking to be successful as an engineering lead on a software project, covering essential topics for that software lead role and answering questions. So you can go to youtube.com/clearmeasure to check that out. And we have a returning guest on the show today. We have Daniel Roth. He's back. He was on the show several times, but last on episode 274. And Daniel Roth is a product manager, a principal product manager on the ASP.NET team, working on ASP.NET Core, Blazor, and other web features. And he's previously worked on various parts of .NET, including System.NET, WCF, XAML, and ASP.NET. His passions include building frameworks for modern web frameworks that are simple and easy to use. And Daniel, welcome back to the show. So great to have you. How are you, sir?
I'm doing great. Hi, Jeff. It's great to be back. Thank you for having me.
Absolutely. Absolutely. You've been on the show several times now, but every time there's just a massive amount of information that's new because you guys are moving so fast. And I want to ask you about it. But before we quite get into that, there's, every time there's new listeners who are coming to the show and new developers who maybe haven't heard you speak before or whatnot. I kind of want to back up a little bit. What are maybe just some of the high points that led to you being like the main product manager for ASP.NET? Is there a turning point that you remember?
Well, I don't know. Maybe it's just getting old. I don't know. being around for long enough. So I have been working on ASP.NET now for it's over a decade. Maybe 12 years, I think. I started more on the back end, like not less on like front end web development, more on back end services, like back in the days of. Do you remember ASMX?
Yes.
ASMX web services and SOAP services and those types of things. When I first joined Microsoft, that's where I started my career. So back-end services, service-oriented architecture, all that jazz. And then I moved on to ASP.NET a little bit later, and we started this huge journey. Like I remember still Scott Hunter, who was over ASP.NET at that time, and he sat me down and said, "Dan, we want you to come work on ASP.NET, and we're going to take parts of .NET open source." Mm-hmm. And it was like, what are we doing? Like, it was amazing. And I was like, prior to that, everything was closed source and it was just part of Windows. And we then, made MVC open source, I think was the first part that we did. And eventually all of .NET became open source. And we started working on the cross-platform support in .NET Core with the whole .NET Core wave. And so I've been riding that train for a little while, and had an opportunity to take a broader role. obviously I've been working very heavily on front end parts of ASP.NET Core more recently, like with Blazor and also MVC and Razor Pages. But had an opportunity to take a broader role to work on the entire web framework. So I think a little bit of history, context, and experience helped out with that. But yeah, that's kind of how that happened. I don't know if there was like a specific turning point other than we just needed to have make sure we have a cohesive vision across the web framework, that we're thinking about both sides of the wire, front end and back end, and making sure that full stack development story is really great, and had an opportunity to do that. So I said, yes, please, I'd love to do that.
Yeah. Well, one thing that strikes me, I'd love your commentary on it, is this notion of front end, back end. And because I've been a programmer since 1997, I don't remember those terms ever being talked about in any popularity before the JavaScript web framework came about. And looking back on it, it's like, well, when they came about, it was a front end framework that kind of was very different than what was running on the server. And so it seemed like, okay, yeah, it did make sense for people who, there was so much complexity on either side. And just my outsider, because you're the insider, Blazor to me, it kind of blows up that paradigm, because you don't have to have a deep specialist front end, back end just to be effective. You can actually have both skill sets and be productive. But that's is that a part of conversations? How do you see that paradigm?
Yeah, no, Blazor enables you to use the same .NET skill set, your C# skills, your understanding of how, Visual Studio, the .NET tool chain, the SDK, how all that works to do both front end and back end development. I think it's fair to say that there are definitely skills that are very specific to front end and back end development that are going to be different, that you still will need to learn, like HTML and CSS, and front end's all about the user experience and the design of that and the UX patterns, and so there's a lot of expertise that obviously goes into that. So you still there's value in having people like on your team or that people have ramped up in those areas. But Blazor certainly significantly lowers the barrier to entry and makes things much more productive. You don't have to have someone you don't have to deal with the complexity of two completely different developer ecosystems, two different languages, two different sets of build tools, two different frameworks and ecosystems that you're interacting with in order to build your entire app. You can leverage the .NET ecosystem for doing all of that, thanks to Blazor combined with ASP.NET Core. Blazor's part of ASP.NET Core, so it's really using ASP.NET Core for your entire web application. So I think that's a huge value proposition. JavaScript has that too, to be fair. You can do front-end JavaScript and as well use JavaScript for server-side development, and that's certainly a valid pattern that a lot of people use. And I assume it's the same value proposition that they get there, right? If you know JavaScript, and that makes a lot of sense, you get a lot of value out of that. Some of the strengths I feel like we get with .NET is, .NET on the server in particular is very strong. Like we have, I think, arguably the fastest runtime on the planet. We're really built for enterprise style applications that need to scale. Like some of the biggest services on the planet at Microsoft are all built on .NET. Think Exchange, think Bing, think Dynamics, all these huge products. Those are all powered by .NET backends. Many of them also are using JavaScript on the front end, and that's perfectly also a valid thing to do. Blazor's one option, but using front end JavaScript may also make sense with a .NET backend if you really want to, optimize that front end experience for really fast load time, and you're trying to hit like a global market and those types of things. But for many cases, Blazor's a big productivity boost and time saver.
Yeah. And your team has been busy from November when .NET 9 kind of released and all the Blazor and ASP.NET stuff there until now, .NET 10 Preview 1. So for developers who just heard .NET 10, what? Can you catch us up?
And we just shipped .NET 9, and we did. .NET 9 just came out in November. It's still pretty fresh off the presses.
Yep.
And if you haven't upgraded to .NET 9, you should. There's lots of great stuff in .NET 9, lots of great performance improvements. I don't know if you've seen the latest, we call it the Stephen Tobe tome, the giant blog post of all the perf improvements that comes out with each release. It's part of our culture really to focus on perf every time we ship a new .NET version. So there's a ton of performance improvements. Memory working set is significantly reduced in .NET 9 because we've turned on the new GC that really optimizes for reducing your memory overhead. We also did some throughput improvements in the JSON support for like minimal APIs and ASP.NET Core APIs to improve serialization of the JSON endpoints, which improves throughput. So a lot of good perf improvements and a lot of big functionality enhancements as well. New C#, of course, and all the improvements that come in the core libraries. In ASP.NET Core, we now have built-in support for Open API spec generation. In the past, you may have relied on like a library like Swashbuckle to deal with your Open API needs, and it's still a great open source project. I think they went through some changes in management, and that was a little bit of a bump in the road for them. But I think they now have a new project owner, is what I understand. So they're churning along. But Open API has really become sort of a core aspect of API development. Like it's a big part of even like with AI, like integration with AI services, like leverage the Open API specs. So we decided, we really need to bring this in to become part of the platform. So we have that built in now. You can just use the built-in APIs for generating Open API specs. We did a bunch of work to optimize how static assets are handled. Like if you have static files in your web application, we now will do automatic pre-compression of those static assets at build time. It's very similar. If you're familiar with Blazor WebAssembly, we've done this for Blazor WebAssembly files for a good long time. Like your all the code and the runtime that gets downloaded to the browser, we would pre-compress and optimize those things. Now, if you just have like JavaScript files or CSS files, whether you're using Blazor or not, if you're just using static files, we'll do all sorts of optimizations. We'll pre-compress them. We will fingerprint them so they have a unique hash, so they can be very aggressively cached in the browser, and you avoid all the like stale cache problems where the file changed but the name didn't. Well, because they're all nicely fingerprinted now, right. you don't hit any of those issues. So static web assets is significantly improved. We improved the Blazor server reconnection experience. Like Blazor server is this kind of very unique model to .NET where you're building a rich interactive web app, but it's connected with the server. Like it has a real-time connection with the server that's handling all the UI interactions, which is really great for productivity. Like it makes it really easy to build those types of apps. But if the connection goes down, then the UI stops working. We did a bunch of refinements to how that when Blazor server tries to reconnect with the browser, how that reconnection experience is handled. There's a new Blazor hybrid plus Blazor web project template. Like if you want to do mobile, desktop, and web, and just have that all set up for you, we have a new template that does that. Just lots of great stuff. Like lots of new features. Strongly recommend. 5 out of 5 stars. You should upgrade if you haven't already.
Yeah. And even the .NET 10 Preview 1 will include a link to the article on devblogs.microsoft.com that kind of gives the rundown. But it also is listing out the new C# features that can be used in that release. So that's pretty cool. The field-backed properties. And I mean, that language keeps on moving along.
I know the C# team is also very active in like engaging with the community on defining those new language features. They have a really great collaboration with folks in the .NET ecosystem. So if you're interested in that, you should call in and join those conversations and help shape the future of C#. Yeah, .NET 10 is our next long-term support release. Like every even-numbered release in .NET is an LTS release. .NET 9 was a standard term support release. Still same level of quality. Doesn't change like the amount of care and consideration we take in the quality of the release. It just means that the support duration is shorter. I think the standard term support releases are 18 months and long-term support releases are 3 years. It is just shipped our first preview, and you can expect preview releases of .NET 10 from here until we get to the stable release. And the planned timeframe for that, again, is November. We ship every November. There's a new major .NET version. Usually the first preview release of a .NET, a new .NET version is fairly light. Like it's mostly like, okay, crank the build system again, make sure we can still build everything, and sometimes we always are optimizing our engineering systems, just making sure that things are working properly. But there actually are a few nice improvements in Preview 1 that are worth taking note of. For OpenAPI, we're still, when we just shipped the new OpenAPI support in .NET 9, and so we're now adding additional improvements, enhancements on top of that. In Preview 1, we now have OpenAPI 3.1 support, which is the latest version of the spec. From my understanding, this version of the spec has some updates and improvements to, particularly around like the JSON schema, like how the types are represented. Previous versions of OpenAPI had some like custom JSON schema constructs that they used, and in 3.1, those things all got standardized in a non OpenAPI specific way. So OpenAPI now is using those new JSON schema constructs like for nullability and so on. So that's now available for you to try out. It is worth noting that that did involve some like breaking changes in the API structure because the semantics of the documents has changed. The underlying APIs that are used to now manipulate OpenAPI docs have changed. So if you're trying to move to 3.1, there will be some breaking changes that you'll need to accommodate. It does still support generating 3.0 docs if you wanted to still do that. So that's also an option if you need to maintain compatibility on the wire format on the generated document. YAML support for OpenAPI also landed. So in addition to the standard JSON format, there's also the standard YAML format now that's supported out of the box. And I know we have a bunch of other OpenAPI improvements that are planned in this release that aren't in Preview 1, but that are still coming, which is probably a good moment to mention that in addition to starting to ship previews, we have also now published our roadmap. The ASP.NET Core roadmap for .NET 10 is now available and published on GitHub. You can find it at aka.ms/ASP.NET/roadmap. So things like, I know the OpenAPI folks are planning to support taking the XML doc comments and using those to provide additional metadata into the OpenAPI specs. Support for creating authentication metadata into your OpenAPI specs based on your authentication config in your ASP.NET Core app. They're working on that. There's a couple others. What is it? Like improvements to build time support for OpenAPI generation. Like if instead of doing it at runtime, if you want to just generate the spec at build time, they're doing a bunch of work to improve the tooling around that. Yeah, those. I think that's the main set there.
I see a SignalR client for Swift for iOS applications.
Yeah,
directly to SignalR. That's awesome.
Got to have SignalR in all the places, so that's being worked on. Yep.
Yeah. Now, for the longest time, it's been kind of a decision between WebAssembly and server side, and there's the automated where you can start server side and then switch over to WebAssembly. You have so many developers and so many applications now out there among Microsoft customers that have done this. I'm wondering, has any dust settled on some guidance or some certain things that y'all have noticed so that you have? Can you give any architectural suggestions like, okay, in these general scenarios, we're finding, 80% of the time you want to pick that one, and these other scenarios, 80% of the time you want to pick the other.
Sure. The like how to architect your Blazor web app guidance. Well, the default Blazor web app template is set up to be a server rendered application and uses interactive server rendering. So it's a server centric pattern, and that is very deliberate. Like if I were to start someone out with Blazor, I would start them there. It's like use the server, use static server-side rendering where appropriate, and then add interactive server-side rendering where you need that rich interactive experience. And there's a couple of reasons for that. One is that it will be the simplest development experience. Everything's happening on the server. You have access to all your server resources, like your databases and any backend services that you need to talk to. You're not having to think about, okay, is this code running on the client or is it on the server, and what does that mean? You don't have to reason through that because everything's consistent. It's all just executing server side. Mm-hmm. You're also leveraging the power of the .NET runtime on the server, which is full JIT support, server powered execution experience. So that's where I generally start people and say, like, let's start with that, and then talk through their use cases to see, well, do they need something different? I start would start to guide people to start thinking about moving things to the client, depending on what their workload looks like. Blazor server style applications, they are, particularly if they're interactive, they are a stateful programming model, and they're a connected programming model. So you're using your server resources to manage the UI interactions and handle all the UI events as the user is using the app, and you also have to have the resources available to handle all those WebSocket connections. And that does impact the scale characteristics of the app. And I don't mean to say this like that Blazor server can't scale. Like, you can easily handle tens of thousands of users with a Blazor server app, and that's not a problem. If you're talking about something that's going to need to go, hundreds of thousands, millions, like you're going really global scale, and you really care about, or you just really care about reducing your server cogs, like you want to avoid the server cost as much as possible.
Yeah.
Then I would start saying, well, maybe we should then talk about pushing things down to the client. That way, you're offloading work from the server and using the client machine, whatever the user's device is, their CPU, their memory, in order to run the application. There are also cases, I think, where some apps maybe don't have a particularly reliable network environment. Like, I sometimes talk to customers where, they're pushing an app into like, I don't know, like an auto shop, or if things where you don't know what kind of router they got, and maybe the WebSocket connections are flaky, and you just don't want to rely on their network for the app to work. And so pushing things to the client also reduces that dependency and can make the app feel more reliable. They'll still potentially run into issues when they need to eventually do an API request back to the server to send data and all that type of stuff. But it can be a little less problematic if you move things to the client when you're in a less reliable network environment. That's another thing that I would push people to. And then I would even say, going further, that if they are really going for hyperscale and they care about every millisecond of load time performance, like this is something that they really want to optimize, that the whole thing they say that with if you're doing like an e-commerce site, every millisecond of time like potentially is revenue. If you're in that mode of thinking, then I might even suggest, well, Blazor might not be the best fit then. Like, you might want to think about actually writing that in front-end JavaScript, which is, again, totally supported, something you can do. We have templates in Visual Studio that facilitate setting up an ASP.NET Core backend with a JavaScript front end, or use .NET Aspire, which has great support for integrating front-end JavaScript projects with a broader distributed application. So that's kind of how I think of. I think of starting with a server and then slowly, should we start leveraging WebAssembly depending on what your use cases are? The more WebAssembly, more client really you start rolling into the picture, there's additional complexities that you have to start thinking about. Like, well, when my component's running on the server versus when it's running on the client, I need to make sure it can work in both places. Like, if I'm going to, you often want to pre-render the component first to get some HTML down. And then when you're on the client, you need to get the component running interactively, so that on the server, it's perfectly fine if that component talks to the database directly. But when it's on the client, it now needs to make an API call. This usually involves like setting up some sort of service interface and then having two different service implementations, one for the server, one for the client, that handles those situations. This is kind of what you run into when you start mixing in WebAssembly into the app. So that's why we try to only take on that additional complexity if you really need it. But for many apps, that's what you want, and it's totally doable. It's just a little bit of extra work.
I'm curious why you mentioned for the super snappy initial load, the JavaScript frameworks, instead of maybe just server side, Razor rendered, because the JavaScript framework, they're still pulling down just as many big old .js files as the WebAssembly DLL. So
I think that there's an additional, criteria on that, and you're trying to do something interactive. Like, if you have an experience where you really need that rich interactive experience, where you need to be able to handle a UI event from the browser and react to it on the in the DOM, and it requires more than just a form post. Like, you can get, you're absolutely right that you can get pretty far with just static server-side rendering and traditional, forms-based UI without requiring any JavaScript or any sort of interactive features. And if you can, you should, because that's going to get you the fastest, most interactive experience possible. But if you need interactivity, like UI interactivity, in order to do that with Blazor, either you have to set up the WebSocket connection, which that is fast. It has a little bit of extra latency associated with it, depending on how close the server is to the client and how fast the network connection is. But the initial load time should be good. If you need to push that to the client, now you're talking about downloading and booting up the .NET WebAssembly runtime. And there's obviously overhead with that, particularly if you're like on a low powered, like mobile device, then it might be a little bit more sluggish than you want. I'm just highlighting there is a trade-off there that if you were to write that same code in just pure JavaScript, obviously you're going to be able to make that smaller, and the runtime's already in the browser because the browsers include the JavaScript runtime, and you can get a load time performance boost by using JavaScript in those cases.
Yeah, and if I'm in the architect role for that type of application, I'd be looking for what are the small handful of pages that really need those characteristics, knowing that the bulk of the rest of the application probably doesn't universally have that type of constraint.
Agreed. Yep. I think people often pick an architecture without like considering some of those things, like when they go full on SPA style application and they don't think, well, but wait, this is just like a mostly read-only data, right? Like, why are you downloading this big chunk of JavaScript just to like display some read-only data? You don't need to do that. You know, those type of considerations are important, and you should think about them. Also kind of depends on the app. For some apps, it may not matter, right? Like whether you're downloading a big bundle of JavaScript or the .NET WebAssembly runtime, who cares? Like if you're just building a line of business app that's going to be used by 10 to 100 people, might not be important at all. And then you should just use the most productive thing you can. And I would say for .NET, like that Blazor server style programming model is super awesome in those cases. Yeah. We have tons of apps like that around Microsoft where people needed to quickly build a productivity app for not a huge number of people, but we have apps internally at Microsoft that are built with Blazor that do handle tens of thousands of users. Like our sales compensation app is built with Blazor, and that has a big spike of usage once a year where it jumps up to tens of thousands of users and so forth. But those apps are just really easy to build with Blazor, and Blazor saves you a bunch of time as a result.
Yeah. I talked to a lot of development teams who just asked the question, okay, when should I use WebAssembly or should I use server side? And when you mentioned the CPU and the memory being used on our server, on the server side component, and then we can use the client CPU and memory when we use WebAssembly, I think that right there seems like the biggest objective difference, which translates into economics and how much you pay if you're going to host it in Azure or whatnot. And that's objective. Just knowing, okay, WebAssembly, we can use that whatever client machine, that CPU and that memory for whatever code is running. And on server side, whatever memory footprint we need, whatever CPU, it's going to be on our server. And some applications that's small, some applications that's big.
Yep, exactly. That's part of the architecture exercise when you're thinking about how you should set up your application. With one interesting architecture concern with Blazor Server that we're actually going to do a bunch of work on in .NET 10 is the problem of state persistence. With the Blazor Server app, we talked earlier how Blazor Server apps are stateful. You're maintaining state in memory while the user is connected to the app. Currently, like with previous versions of .NET and Blazor, that state is just held in memory. Like there's nothing that will persist it anywhere. And so some things that can happen if you have a Blazor Server app with a workflow for the user that's long, like they think like filling out your tax forms or doing some big long registration form where you're done a lot of work and you have now accumulated a lot of state. If anything happens to the state on the server, like maybe the server decides to get an update and it has to restart, or maybe the user. One thing that's common is the user maybe they go to lunch and the app, like the tab in the browser, or maybe if they're on the phone, like maybe they swipe away from the app. Mm-hmm. If the browser goes into a state where it decides, what, I don't need that WebSocket connection right now, so I'm just going to close it. When that happens in a Blazor Server app, that by default will start a timeout on the server. The server has all this state, but the connection to the user is gone, And so should it hold on to it? Well, what Blazor server will do is it will wait up to, I think by default, like 3 minutes and say, well, is the user coming back? Are they coming back? It doesn't look like they're coming back. And then it will free up that state so that it's not just holding on to it.
Yeah.
And then if the user comes back from lunch and tries to reconnect to the app, they might be like, wait, where did all my progress go? Today, this is a very manual process to handle that problem in your app. You have to manually figure out, okay, what state do I want to persist, and when do I want to save it, and where am I going to save it, and all these types of things. In .NET 10, we're working on trying to provide a more out-of-the-box persistence model for dealing with that state, like having a declarative way to say that, hey, I have this component, it has these things that I really need to be persisted and to be saved someplace. Having ability to manually say I would like to persist the state either on the client, like putting it into local storage in the browser, or potentially on the server if the client connection is not available. Like maybe you want to that circuit looks like it's gone idle, and you want to just save it and then be able to rehydrate it later. That can help with your scalability characteristics. This is a problem area that we're expecting to spend quite a bit of time on in .NET 10. Is really sort of our main focus for Blazor. And we hope to really make it easier to deal with these state persistence problems.
Nice. Yeah, that is. I mean, I've ran into that situation. It's just a question. We could increase it from the default to maybe a few minutes, but we don't want to increase it to an hour, because then it's just memory bloat we have to wait for an hour to see if somebody's going to come back. That's a lot of memory footprint now just sitting around being consumed. You'd have to go to one of the larger app service instances just to make that even functionally work because of the memory footprint. So yeah, that is. I mean,
it could potentially become honestly a security problem if you do that. Like if you're in an environment where some malicious user could open up a bunch of circuits and then just close the connections and go away, and now your server's holding on to that state for an hour or however long you've bumped up that time limit to, then they're potentially taking resources from your server. So you want that time limit to be reasonable. You don't want it to be super long unless you know you have a really trusted environment. Having a way to be able to say, I'm going to take this circuit, I'm going to save it, I'm going to persist its state someplace so I can reload it later. That will result in a much more robust experience for end users, so that when they swipe back to their app on their mobile phone, their state's still there, like they're still in a good working situation. And you can also reduce the load on your server if you have a bunch of circuits that are currently idle.
Yeah. As we kind of get to the end of the time here, one of the features that doesn't really get talked about that much, but I found is incredibly useful, is to the attention to detail that y'all have gone to emit very useful telemetry to application insights, things beyond just the .NET framework around like these connections and disconnecting sessions and who's connected and how many are disconnected, so that they can be put on a dashboard, because then just automatically out of the box, there's that little line graph with here's the number of currently disconnected users that you have where we haven't thrown away the memory yet. I mean, just that right there being built in, really helps. So I don't know.
And we're planning to do a lot more in 10. In 10, one of the big sort of work areas that we're focusing on is also like observability and telemetry and diagnostics. We've been, and this has been a journey. Like we've been adding more and more metrics, for example, to ASP.NET Core to give you counters and sort of numeric insight into what's going on in your application. We're planning to add more metrics for Blazor, for the SignalR client, and in the authentication and authorization space, we're planning to add metrics, and some stuff down in Kestrel like the memory pool, having metrics around that. We're also we know we also have a longstanding problem with like Blazor server where for tracing, like distributed tracing style views of your system, Blazor server just looks like one big long request. You don't get a lot of insights into like what's actually happening in that circuit. We're planning to add Blazor server specific activities in .NET 10, so you can have a much more fine-grained view of like what is happening with this particular user. How are they flowing through the logic of my application? There's even some work. I know there's some open telemetry work planned in 10 as well to like make the tracing support compliant with the latest open telemetry specifications and have that be built into the box, so you don't have to like grab some other community library in order to enable that. On the diagnostic front for Blazor WebAssembly apps, we have had been a longstanding gap that we don't have a good way to do like performance profiling and like memory diagnostics on your Blazor WebAssembly app, particularly if it's in like production. We are working in 10 to add a tooling and story for doing that, so you can track down those perf problems on the client when it's .NET code running inside of a browser on WebAssembly. Having a way to do that is also something we want to address.
Yeah, that's huge. Knowing what the application is doing at all times, so that when a user reports a problem, and even getting a signal that a user's probably having a problem even before they complain. I mean, just that's so important.
Super important. And all that data in the dev experience can be really useful for just developing your application. Like the Aspire dashboard will grab all those metrics and grab all the tracing information and just make it fingertip accessible while you're developing. So if you're trying to track down some problem in a distributed flow from your Blazor app, talking to some backend API, having all that data plumbed into the Aspire dashboard really makes that much simpler to do.
Yeah. And kind of final question as we wrap up here, more philosophical, but the Blazor framework is for building web pages, and the paradigm of web pages is to lay out information in a browser, and then of course you got forms, you can type in text boxes and select things. Have y'all had any internal discussions trying to think, okay, is the nature of the web user interface changing as we integrate AI technology and large language models and agents? Like, is it a click on text boxes type of paradigm for how to interact with
the AI topic? I think yes. I mean, we're already starting to see a lot of these sort of UI paradigms change, where instead of you having to have very structured UI elements, where the UI elements have to kind of reflect the data that you're trying to gather from the user. Instead, you have natural language. Like you have you could just talk to something, to a bot, to a chat agent, and they can just understand what you're saying and collect the information. I saw a really fantastic demo from Steve Sanderson, who's been doing a lot of investigation in web development and integrating with AI, where he had a web app that had a form, like it had traditional checkboxes and combo boxes and whatever, but it also had an audio interface where you just talked to it, and it had an agent that would talk back to you. And I think it was for like selling your car, like an auto dealership type of thing, and you were supposed to like enter in the details about your car and what condition it had. And you could manually do that with all the UI elements, or you just like click the microphone button, and then this agent started talking to you and said, "Hey, like tell me about your car." And you start talking to it and say, "Well, I have this make and model, and it's got the rear wheels are kind of rough," and you just talk, and then you watch as all the fields in the form just start filling in. That's those types of natural, more free-form interactions really become enabled by AI and the generative AI systems. And so being able to plug into that from .NET applications, from ASP.NET Core applications, Blazor applications, is something that we are spending a lot of time and effort on. We have the new Microsoft Extensions .ai, I think is the new library that really has a bunch of abstractions around interfacing with chat AI services, so that you can use them in your .NET applications. I think Blazor Server in particular is awesome for these kinds of apps, because often with these types of apps, you want to stream the interactions back and forth with the user, right? You want to stream the responses from the AI down to the UI and have it update, and you want to be streaming whatever the user's typing back to the service. And that's kind of inherently part of how Blazor Server works. So they're really convenient to implement when you're building it with a Blazor Server app. So I think we're definitely in a paradigm shift, and it's really fun to see the types of stuff that you can build with these technologies.
Yeah, we will see. So, well, Daniel, thanks so much for coming back on the Azure and DevOps podcast to let us know all the new web goings on with .NET 10 preview on and beyond. Appreciate it.
Always a pleasure. Thanks for having me.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.